fill out the Google form. Okay, and if you haven't sent me an email, so please do it after the class, so that I can have your emails, and when I have something to communicate with you, then I know like which emails I can use. Okay, and other than that, I think there's no problem to enroll in this course. For now, because the semester hasn't started yet, so there's no way you can enroll the class right now, the course right now. Okay, but you can do it like when the semester starts. And you can also do, I don't know how to say 加签 in English, but I guess you know it, right? Like additional enrollment or something like that. You have to bring out give me a font for me to sign it up, and you can get the magical green pieces of papers. You know what I mean? At least that's what we did like 10 years ago. Yeah. Right, so other than that, any questions? No? Good? What? Right, then we are going to talk about the functions. Okay, so what is the function? The function is if according to the definitions here, is that the easy way to use it? Okay, so a function f from x to y, meaning that we will assign each elements of x in a bigger set, capital X, to unique elements in big Y here, and we can write it as f of x equals y. Okay. What does that mean? Okay, so if I use it like I put it down in graph, so it will look like this one. The function f will transmit elements in X to the set Y here, one element of in the set Y here, right? And this big X or capital X, we'll call it domain because it is the function, the input of these functions, we will call it domain. And all the elements of X, so I can write it down this way. So if we transmit all the X to Y, then we will get the collection of all f of X here, and we will call this image. Okay, so this is all the elements here. You can find the corresponding part here. For example, I call it x1, x1, and the rest. Okay, so it is possible that the image of x is just a proper set of big Y here, and of course it can be equal as well. Okay, but it doesn't really matter. Okay, and we have a few properties here. For example, like if we say the functions is a one-to-one functions, then that means what? Okay, if this function f is one-to-one functions, we call it case 1. Okay, case 1. Then that means here is the more formal definition. F of x1 equals to f of x2 imply that x1 and x2 are equal. So that means it's 1-to-1 as I put it in there. Okay, and case 2 is the onto. It's a onto functions. The definition is that for all elements in big Y, there exists x in big X, such that fx equals to y. How can I show it in the graph? So it looks like this one. So let's say that Y only contains 2 elements here. And for all the elements in big Y, there exists a small x such that fx equals to y here. So if we have a function look like this one, this is also onto, because we can find elements in x such that fx equals to y. And all elements in y, we can find such relationship. Okay, no. In y, we can find in big X such that fx equals to y, right? For all. Right, so that is the onto functions. And the last one would be bijections. That means the function is one-to-one and is also onto. So in that case, we'll return 2. So this will be the cat 3. I should okay. Sorry, let me do it again. I think there's a little bit confused by my own note here. This is case 1. Okay, so let me do it again. So we have three type of functions here: one-to-one, onto, and bijective or bijections here. For the case 1, this will be a one-to-one functions, even though there are elements in y, which I highlighted in red here, is not assigned by this function. But that's also fine because I say that the image of the function f could be smaller than the big Y, right? So this is the example. But this function is still one-to-one function because according to our definitions, like this function